Welcome to the video on operators in TensorFlow. Firstly, let's understand what are operators. Okay, so basically TensorFlow provides certain predefined operators that can be performed on tensors. So suppose if you want to perform any operation on tensors, so you would be needing operators. These operators, like if we talk about numbers, so we have operators, right? Addition, subtraction, multiplication, division, modulus and all, right? So those operators are on the numbers, right? But since here we are talking about tensors, so we need the operators that can actually take tensors as parameter and evaluate some result depending on the operator that is used, right? So there are several types of operations that can be done in TensorFlow. Now the sum of them which are most often used are arithmetic operations, matrix operations, control flow operations, logical operations, comparison operations, and debugging operations. Okay, and we'll be going through each of these operations one by one in detail in the further part of this video. Okay, so let's see what are the arithmetic operations in the case of tensors. Okay, so TensorFlow provides several operations that can be used to add basic arithmetic operators to graphs. Okay, so for example, you can see here tf.add, tf.subtract, tf.multiply, and so on. Okay, so basically these are the operators that take parameters as tensors, okay, and they do element wise computations. For example, this tf.add, okay, so it will take two tensors as parameters along with some other parameters, but yeah, two tensors will be taken, and then there will be an element wise addition of the two tensors. Okay, so the return value of this operator will be a tensor, which is essentially the tensor that has been formed by adding the two tensors that were given as parameters element wise. Okay, next we go on to matrix operations. So TensorFlow provides several operations that can be used to add linear algebra functions on matrices to graphs. Okay, so we had seen in previous video that tensors are effectively multi-dimensional arrays, okay, multi-dimensional matrices you can say, right? So these matrices, they can have a diagonal, they can be transposed and so on. So if we consider say a two-dimensional matrix which is essentially a tensor of rank 2, so in that case we can actually find out the diagonal of that matrix, the trace, the transpose, and so on. So here we can see a list of matrix operations that can be performed on tensors, right? So let's pick up the example of tf.diag. Okay, so essentially this operator, it will take up a tensor, okay, and then it will return a tensor which will has all the values that are essentially the values that are present in the diagonal of the tensor that has been given as the parameter to this operator. Okay, so similarly there is a huge number of matrix operations that can be performed in tensors. So yeah, I mean not all of them are very frequently used, some are frequently used. Okay, so I'll add a link to all these operators in the video description so that if you want to use any operator, so you can just go on to that link and just search right there, so it will be very easy for you to find further details on that operator. Okay, next let's go on to control flow operations. So TensorFlow provides several operations and classes that can be used to control the execution of operations and add conditional dependencies on the graph. Okay, so basically you can see a huge list of control flow operations here. So like you can see that tf.identity, tf.tuple, and so on, tf.while loop, tf.case, tf.con, right? So essentially this, I'll just give some examples. So that's tf.while loop. So this is essentially used to apply the while loop logic to your program. Okay, this tf.case, so it is essentially like a switch case that you must have used in earlier in some other programming languages. So the switch case, right? So this can be implied in TensorFlow using tf.case. tf.tuple, it basically takes up the tensors and groups them together in the form of tuples. So I mean, these are the operations that can be used to control the execution of operations. And yeah, you can add conditional dependencies, like for example, you can check for condition before executing something, you can do switch case and so on, right? Next, let's go to seeing what are logical operations in the case of TensorFlow. So TensorFlow provides several operations that can be used to add logical operators to graph. Okay, so for example, tf.logical and, tf.logical not, tf.logical or, tf.logical XOR. Okay, so these are the basic logical operators. So what happens is that, suppose if you have tf.logical and, okay, so this will take two tensors as the parameter, okay, and then it will return a tensor which will actually have the values of logical and that has been taken element wise for the two tensors that have been given as the parameter to this operator. Okay, similarly in the case of logical not, so basically we'll be getting a tensor that has the values, the elements that are essentially the element wise not on the parameter tensors, right, and so on, like for these remaining two operators as well. Next, let's go on to comparison operators. So TensorFlow provides several operations that can be used to add comparison operators to graph. Okay, so for example, tf.equal, tf.not equal, tf.less, less than, less equal, greater, greater equal, tf.where, and so on. Okay, so basically, let's take the example of tf.equal. So in this operator, you will be giving two tensors as parameter, and the result of this operator would be a tensor which has Boolean values. Okay, so essentially what happens is that the result, the output vector, the output tensor in this case will be Boolean, and each element of this output tensor, it will be denoting that if and whether the corresponding elements of the input parameter tensors were equal or not. Okay, so suppose we have two tensors in which, say, the first elements are equal. So in that case, the first element of the output tensor would be equals to true. Okay, it is a Boolean one. And suppose if, say, the fifth elements of the two parameter tensors are not equal, so in that case, the fifth element of the output tensor will be false. Okay, in this case of tf.equal. And similarly, we can apply the similar logic for tf.not equal, less, less equal. All of them will result into Boolean tensors. Okay, that will denote the element wise comparison of the parameter tensors. Okay, now let's go on to debugging operations. So TensorFlow provides several operations that can be used to validate values and debug graph. Okay, so tf.is finite, tf.is inf, tf.is nan, and so on, right? So essentially, these operators, they also result into Boolean tensors. Okay, and what happens is that these output tensors, they denote whether the corresponding so each element of these output tensors, it denotes whether the corresponding element in the input parameter tensor, was it satisfying the condition or not. So I'll just give an example. Suppose let's talk about tf.is finite. Okay, so this will take one tensor as an input parameter. Okay, and after this operation is done, it will result into a tensor which has the same structure as that of the input tensor. Okay, and each element of the output tensor will denote whether the corresponding element of the input parameter tensor, is it finite or not. So if it is finite, then we'll have a true value in the output Boolean tensor. If it is not finite, then we'll have a false value in that corresponding element in the output tensor. Okay, similarly, this is inf checks for infinite values, this is nan checks for nan values, and so on, right? So in this video, we learned about operations, the basic operations of TensorFlow, okay? The link to the official TensorFlow docs that has details of all the operations, it has been attached in the description of this video, so you can use it for quick reference, okay? And yeah, so this was a theory aspect of the operations. When we move on to actually programming using TensorFlow, so you can see at that point of time, all these operations and all will come handy. So it is important that you become comfortable with these concepts beforehand.